Worldwide, more than 700,000 cases of liver cancer, also known as hepatocellular carcinoma, or HCC, are diagnosed each year, with over 20,000 new diagnoses in the U.S. and over 400,000 in Asia. Depending on the stage of the cancer, patients are typically classified into one of three groups for treatment: Group A, B, or C. Group A accounts for approximately 25% of all U.S. patients. Their treatment options include transplant, resection of the liver, or radiofrequency ablation. Patients in Group B, with an intermediate stage of cancer, are typically treated with a procedure known as transarterial chemoembolization, or TACE for short. Approximately 35% of all U.S. patients receive TACE. Advanced stage Group B patients may receive sorafenib chemotherapy as treatment. Group C patients have the most advanced form of HCC, and treatment is generally palliative only. TACE is an interventional procedure where a catheter is passed through the femoral artery and into the hepatic artery, from which tumors receive about 80% of their blood supply. Embolic particles containing a chemotherapy agent are injected through the catheter, which interrupt that blood supply and create a hypoxic environment, killing tumor cells and inhibiting growth, as well as delivering a focused dose of chemotherapeutic agent. But the tumor has a defensive weapon against this method: the HIF-1 alpha protein. The hypoxic environment created by TACE inhibits degradation of this protein, which, in turn, activates several other genes responsible for tumor cell survival, metabolism, angiogenesis, drug resistance, and metastasization. The proteins coded from these genes complete the survival response, enabling the tumor to survive hypoxia, rebuild vasculature, and resupply the tumor with blood and oxygen. Even though cells in the tumor's interior have been killed, exterior tumor cells survive and thrive as their blood and oxygen supply returns. PhaseRx hopes to interrupt a tumor's ability to rebound from TACE and thereby extend patients' survival times. PhaseRx has developed a novel siRNA polymer conjugate that targets HIF-1 alpha, downregulating the gene via an RNAi mechanism. The siRNA polymer conjugate is administered in conjunction with TACE, leveraging this standard of care procedure. Using the same catheter, the siRNA polymer conjugate is injected into the hepatic artery prior to injection of the TACE beads. As the conjugate travels through the tumor's vasculature, the conjugate binds to the membrane of tumor cells and is invaginated into them via endosomal action. Once inside the cell, the conjugate escapes from the endosome, releasing the siRNA into the cytoplasm, which cleaves the HIF-1 alpha mRNA via an RNAi mechanism, inhibiting translation of HIF-1 alpha mRNA into HIF-1 alpha protein. Elimination of the HIF-1 alpha protein effectively interrupts the entire gene cascade. Downstream genes encoding proteins responsible for vascular growth, such as VEGF, and anaerobic metabolism, such as LOX, are not turned on. This will effectively disarm the tumor's survival mechanisms, further inhibiting tumor growth and increasing tumor cell death. The addition of PhaseRx's siRNA polymer conjugate to the current standard of care treatment, TACE, can further delay time to progression beyond that of TACE alone, extending life expectancy and enhancing the quality of life for those affected by liver cancer.